Can you solve this integral? To solve this integral, we would need to perform a trigonometric substitution. So, we know from the Pythagorean identity that sine squared theta plus cosine squared theta is equal to 1. Rewriting this, we get that cosine squared theta is equal to 1 minus sine squared theta. Now, if we observe, this term is very similar to our term inside of the square root. So, we can perform a substitution where x will be equal to sine squared of theta. Now, when we perform substitutions, we make sure that the dx becomes whatever variable we're integrating with respect to. So we have to take the derivative of this. It becomes dx d theta is equal to cosine. This shouldn't be a squared. The x is just sine theta. Cosine of theta. From here, because this is the first derivative, we can treat it as a fraction. So we just multiply this d theta over to this side, making it cosine theta d theta is equal to dx. Now, with our substitution, x equals sine theta, we write this integral as the integral of 1 divided by 1 minus sine squared theta cosine theta d theta. Now, this, as we saw before, is equal to cosine squared theta, and because we're taking the square root of a square, these can just cancel out. Now we would have 1 divided by cosine theta times cosine theta with respect to theta, which basically means these also cancel out, so it becomes the integral of 1 with respect to theta, which in turn becomes theta plus c. But as our original question was in terms of x, we have to make sure that this is in terms of x as well. So x is equal to sine theta was our substitution, therefore theta is equal to the inverse sine of x. Plugging that back into this equation, we get that this integral evaluates to arc sine x plus c. And that's our answer.